So we have our, we're going to make a function to do that. It's important that you always know where the brackets end, type of a situation, because you don't want to have a function in another function that, well, unless you want it to be there, but you don't want to declare a function inside another function. I think that'll actually, I know that'll actually give you an error in basic C up to at least C99. Because it should be. But anyway, moving forward. So we got public static void shuffle, and just like this little make deck function, its arguments are going to be an array of cards. In this case, we just call it deck to be, or this whole thing is going to be poorly optimized. So the way I'm thinking of doing it is we're going to have a for loop, okay, int I equals 0. Now it's trailing along there. Hopefully it'll pick up in speed a little later. Some number for now. It doesn't. I'll come back to that a little later. I++. Yeah, it is really going slow for some reason. But so there's a standard library in Java called math, and within this standard library there's a function called random, which I'm not sure if you would recognize it right off the top of your head, but it will generate a random number. So we're going to say int rand1 equals random with a capital R, I think. But though this function actually will generate a double. I'm not sure if you hopefully you remember. Basically what will happen here is it doesn't like the statement because it's a basketball. You got to cut this down into something that can fit into here, right? And we're gonna want so after explaining that, the way we are actually going to shuffle is we're just going to generate two random numbers and then switch those numbers in the deck. A double means it could be anywhere from like 0.005 to like 0.9999 or a lot more of those in between. So what we actually have to do is go like this and sort of say, hey, multiply this by 51 because excuse me, had to clear my throat, because the 51 is essentially the number of array indices we're going through. If you remember, there are 52 cards in a deck, but deck 0 is where you start your count, so that's sort of 52 minus 1 is 51. So this right here is going to generate a random number between 1 and 51. We're going to do rand1 then dec rand1, dec rand2, equals temp. The reason we have to do this roundabout way is you can probably actually logic your way through it, right? If you just try an assigned dec of this number to dec of 2, then whenever you try to assign this number to rand1, the deck of rand1, these are cards, not numbers. But whenever you try and swap their values, this will already be equal to this, so you'd be essentially setting this card equal to itself. So before you swap it, you just sort of, hey, make a new, actually we're probably going to need the new keyword operator. No, we don't. Anyway, so you just have to make, the reason it's called temp is because it's just a little temporary card to hold as a placeholder, I guess you'd say, to hold the value of temp. And so this will run through the loop 123 times, generating these numbers and then switching their values in the deck. There is no actual prevention from having these two numbers be the exact same thing, but if you think about it, that's sort of alright, because if you shuffle a deck in real life, you don't really have an exact guarantee that the card is the one card is going to end up in a different index. It can end up in the exact same spot in the deck. But I want to say, we'll try this 200. Obviously my system's running a little slow, so we might shorten this up a bit a little later if it takes too long to run the first time. But since we have officially created this little shuffle function, we already have our little test down here, so we can get rid of that. We don't need that anymore. Step 1 is completely finished. Well, for now. Might want to come back to it later. But okay, so what we have here is, if you recall, create the deck of cards, get every card a value and a suit, print out the deck. So what we're going to do is say shuffle the deck, and we're going to print it out again. But beforehand, we're going to print out just basically a big old line to separate it. Well, not big old, not that big, but just so we know. Doop-a-doo-doo, doop-a-doo-doop-doop-doop. Wish I had something a little more interesting to say. I guess while we're waiting for this, oh, never mind. Okay, so let's scroll up a bit and try and see this. Okay, so here's the original deck, starting with 2 of diamonds, leading all the way down to the ace relationship of. So that's pretty good, but that took a little bit of a while. So I guess for the purposes of this video, obviously is going to result in less shuffling, but hopefully it'll make our compiling, compiling and running, I guess you'd say. Hopefully it'll make that a little faster, so that it'll I won't have to sit here and stare at the screen, not talking and being all creepy. So okay, yeah. What I wanted to, we have some time here. I wanted to actually say a little something about where I messed up earlier with this new keyword. If you don't know, well, I guess I want to say, if you are familiar with basic C programming, new is sort of the malloc plus the initialization. If you are unfamiliar with malloc, if you're unfamiliar with malloc, you're probably unfamiliar with basic C, which is where I was going with. How do I want to say this? Basically, it's for dynamic memory, and I don't think I covered what dynamic memory is, but what sort of happens whenever you run, maybe I can try and very quickly draw something that doesn't suck. Here you go. Whenever you run your program 1200 by 8, no, it's 1240, I want to say, by 8, that your program takes to work with. And it starts off with like reading in your program as just text, because it doesn't want to read in everything. Oh man, that looks awful. But it doesn't want to read to execute things, at least for compilers, because that's sort of how compilers speed up the process. of converting your higher level programming language into language term for that, and that sort of makes me look foolish, but whatever. How many times have you had to that? So whatever, it's fine. So after over and over again throughout the process, I think these two chunks here, around here though, is this is the stack like that, and this is the heap. So the stack actually grows downwards, whilst the heap grows upwards. It's like all of this data memory here gets put like right here. It starts off with here and moves downwards as it grows. Where the heap is sort of as needed basis. This is where all of your dynamic memory goes. This is where if the program on, like whenever you hit that little button, the data is going to be, or it should be, it wants dynamic memory because it allows for a lot more flexibility with variable length sizes. So normally there will be a lot of pointers, which I didn't cover, but I think in another video I said, hey, if you have an integer, right, well, this is an example, not of a pointer, but it's going to be of an integer pointer. Man, that's bad. But, right, so you declare an integer and it says, hey, here's a bunch of memory, and this data, this inside of it, use what's inside of it. An integer pointer denoted sort of by a little asterisk. Well, yeah, denoted by a little asterisk. Says, hey, get this chunk. You don't necessarily care about what's inside of it. The important part is that you have this chunk of memory that is an integer. So that's, in a sense, that's basically what the new keyword is doing. It says, hey, I don't know how big this array of cards should be. I know it's size 52, but I don't know what this, like how big a card is in and of itself. Or for you have an array of things. Wow, this is covering a the drawings normally go that you're familiar with is each one of these lines and each one of these chunks is its own sort of card, right? This is card 1. I think I wrote this out earlier when I was explaining what an array was. But that might not necessarily be all of the case because that might not be the case. Because again with the because, but we made our own data members for this card class, right? Just want to say it has an integer and a string, right? Man, that's bad. String data type. But so what can be the case is all of the data types, and well, they're called data members if they belong to the class, but basically if all of the elements of this card don't fit in one block, it will have to go on to the next block, right? So maybe instead of having this whole bottom row be card 1, it'll be like that. This is, I don't know, maybe it looks like halfway through the block, and you sort of get rid of this line and say, hey, all of this is card 1, and it starts reading at this space, and just sort of whenever it hits the end here, either starts here and continues, or it starts up here and then you just have this block of useless data in the array doing nothing essentially. So I want to say that's what's going on here is whenever we declare a single size card, it just knows, hey, this alignment, because of this alignment. It's not necessarily going to fill out a fixed number of blocks, and it sort of. Is there anything else I wanted to say? I think that might be hand or not. So that's going to be in here. We've completed this. So before the next video, I'm going to have to figure out if I want to like check to see if it's a pair, I guess, for the example. I want to figure out if I want to do that before or after this basic GUI interface. I'm gonna say we might move 5 to 6, and our new 5 is gonna be know if you win, or basically just know how good your hand is, or something like that. So yeah, I'll see you next time. Hope you learned something.